Hello everyone, thank you very much for joining this live event, which is lesson 59 from the Java Fundamentals stream, and we start a new chapter today, which is IO streams. We'll have a few lessons that will deal with subjects related to IO stream because this is a very big chapter and we have a lot of things to discuss in the end. But let's get started today, and of course, as usual, if you are watching the event live, don't forget that you have a live chat there, so you can ask me the questions directly in the live chat. And if you are not watching the event live, if you are watching the event recorded, you can still leave questions in the comment section, or you can find me, of course, as well on LinkedIn or Twitter, and we can discuss there. With this being said, let me share you my screen and we start our discussions on IO streams, which is a subject. First of all, I would have to say you shouldn't make a confusion between IO streams, input-output streams, and streams API, which is a set of tools that appeared in Java 8. So when we discuss about IO streams, we discuss about inputs and outputs and ways in which we can send data. We don't discuss about streams API, which we have actually covered a few lessons ago already. So thank you very much also for your appreciations. As well, don't forget that you have a live chat, so you can write questions if you would like, and if you're watching the event live. Yes, now continuing, we were discussing about IO streams, and first of all, I'd like you not to make confusion between these two. So if you actually want to learn about streams API, I have already recorded a few videos in the past lessons, and you can find them and you can watch them for free whenever you'd like. Just go back and review those videos. Otherwise, I will start now by representing IO streams in sort of a visual, so that you can imagine IO streams somehow, and then we will start with working with examples of implementation, and we'll discuss a few classes that are important. And I want to set your expectations from the very beginning. We will discuss about the things that are mostly important in real-world scenarios. Of course, all of these things that we discuss here are also very relevant for your OCP exam. But be careful that for the OCP exam, you actually have to learn also mostly all the methods from these classes, especially from the input stream and output stream classes, as well as other implementations of streams. And I don't find it very valuable to just take now during our lesson all the methods and discuss them one by one, because you will find them described in the references, and you don't actually need to know all of them by heart for real world implementations and debugging and whatever you do in a practical application. And these are the kinds of details that you actually need to know only for the OCP certification. And you know that the OCP exam asks plenty of things that you don't necessarily, they are details, you don't necessarily need to know them. I personally learned them before an exam or an upgrade exam, and then I generally forget a lot of these details because I don't use them, and they are not necessarily, I didn't see them in my career yet, and I have some years of experience already. So that's why I don't want to actually bore you with absolutely all the methods that are irrelevant of these classes. So what we'll discuss is plenty of details about the classes that you might find in real world examples. And when I say you might find, I don't necessarily refer to like you actually coding with those classes, because IO streams now are a very low level subject that you don't necessarily use to implement by yourself in applications, but they are the backbone of many things. I would say they are the backbone of anything that's related to communication between two applications, two processes, to terminal endpoints somehow. So writing, reading from a file, for example, might be something that you don't necessarily see in more than student examples today, but web services, as well as messaging in general. So sending a message, either way you would send it from one application to another, represents streams. They have streams behind. So when you would actually at a breakpoint, in many situations you had a breakpoint, and if you have to debug something, sometimes you are looking up to the stack and you see at some point that you reach at the end of the stack classes that are part of the IO streams, because everything that's communication between applications is backboned by the IO streams, and that's why it's important to know them. And that's why I say it's not really relevant to actually know by heart all the methods. That's relevant only for your OCP exam, of course, and I recommend you before the OCP exam learn as much as possible all the possible things that you can find in the reference of streams. But for yourself, like for your career and for working with applications, you need to know mostly the things that I will teach you now, and not necessarily all the other details. Now, streams. Again, you can imagine streams as some pipes through which data is sent between the applications. So I really like usually to think as streams as being some pipes, and I see the data flowing on these pipes from one app to another. So you can actually I can actually represent it like a rectangle. This is my pipe, and one very important thing you need to know from the very beginning is that every stream has a direction. So when you have a stream, you always define the direction, you always know the direction the data is flowing. So you can't send the data in both directions through the same stream. And depending on where the application from where we send or receive the data, will actually even classify these streams based on the direction of the data. If data is going into the application, we say that this is an input stream or a reading stream. If the data goes out of the application, then we say that this is that it is an output stream or a write stream. So you need to know from the very beginning you have this arrow, this arrow representing the direction in which the data is flowing. And then you always have, of course, you have the terminal endpoints, because always data it needs to be sent by somebody, by someone to someone. So by a specific process to another process or to something else. So you need to have the two endpoints that communicate one to the other. So this is why, say, on one of the ends of this pipe, I represent this is the first app, and then on the other side of the stream, this is the second app that that communicates. It can be a second app, it can be a file, it can be anything that that you can establish communication with. But for now, we can actually just think these are just some two apps which we can name app 1 and app 2, and that's it. So to send an information from application 1 to application 2, you need a stream, and the stream is the pipe you have here. And inside the stream, data is flowing always as bytes. So when you refer to data, when you refer to data, you usually don't think that data is always formed of more bytes, but that's actually how any application actually sees the data in the end. So in our case here, let's assume that all of these small rectangles, so these small rectangles, you can fill them if you'd like, these represent the bytes of data. So the data flowing in the minimal say unit of measurement for an app, which is not the bit, is the byte. So it's a series of 8 bits. This is how we represent the data in its smallest way an application understands it. And here is actually a problem. When we discuss about data, we think about numbers, characters, strings, object instances, Boolean values. All of these are represented as bytes somewhere behind. So when the JVM sees a specific type and a specific value, it doesn't understand that value as the same way as we understand it. So it for the JVM, and say for the system in general, value 10 might not be value 10 precisely. It's just a string of 4 bytes, because that's an integer. Integer is 4 bytes. So say you store value 10 in an integer, and that's because that's the default Java would see it, then you have 4 bytes that represent that value. So when you send the value 10 from one app to another, so you send the value 10, you actually don't send the value 10 somewhere behind. The app will transform this value in 4 bytes, will send the 4 bytes throughout the stream, and then at the end, so that the place where this is received here, value 10 is again reassembled from those 4 bytes in the value that was sent. But when you actually work with the application, when we send data, you might have never actually transformed this integer yourself in the bytes. And that's where I want to go. Actually, when we refer to IO streams, the real stream, which is that entity, that pipe throughout the information, which helps us send the information, through which the information is flowing between 2 points, is what we actually call a low-level stream. So you will hear this notion. Of course, I will use it a lot of times in this lesson and the next lessons where we discuss streams. You'll first of all have to know the classification, and the idea is that the first kind of stream you need to know is the low-level stream. So this is for the first part of the classification. You have low-level streams, and the idea is that the low-level streams in general are actually the real streams, the streams themselves. When you say a stream, you should think about a low-level stream, which is a stream that sends the information byte with byte, and inside which you will never find numbers, object instances, strings, boolean values, and so on. But the real problem is here that usually you don't think about data in bytes. So when you will send something from an app to another, or from a point to another in your application, you need to send a value like 10. And you cannot actually send value 10 directly through the stream, because 10 is an integer, and you'd first have to split it in 4 bytes and then send these 4 bytes through the stream. And what happens here is that you can do that yourself. Actually, you can transform, there are ways to transform that data into bytes and send it byte with byte. But to make your life easier, the language comes also with some classes that help you do this operation. So instead of having you transforming your data into bytes and then transforming it back from bytes to the number or to whatever that value is, you have these classes that you use to wrap the stream, the low-level stream, and this wrapper above the low-level stream actually is the one transforming this information for you, and then you don't have to deal, you don't have to get any headache about transforming the data into bytes. You don't care about how the data is sent, you just send the value 10, somebody else takes care of transforming that value in whatever you need to send. And that kind of object, that kind of responsibility that transforms the value into what the value should be, and from the value into the bytes, is what we actually call high-level streams. So the high-level streams, they are basically not the streams, the stream itself. The stream itself is the pipe through which data flows as bytes. but because we don't usually use data as bytes, and we don't want to bother with transforming the data from how we understand it and how we use it into how the computer understands it, we use these high-level streams, which are transforming the data for us, and then we wrap the stream, the low-level stream, into a high-level stream. And by this we make basically our life easier. So we can say this one is the high-level stream. You send the value is transformed into bytes, is sent to the other app receives it and transforms it back into a number. So behind you have all this process, and when you hear from now on about a low-level stream and a high-level stream, this is the first classification you need to know. You'll find it in documentation, in references, in books, and even in your OCP exam. Low-level stream and high-level stream first classification. Through the low-level stream, which is the real stream, you send the data. The data is sent as bytes. But then, because you don't want to bother with bytes, because you don't usually work with bytes in your apps, you'll work with numbers, strings, booleans, objects, and so on. You'd like someone else to take care of this transformation. And then you use the high-level streams. They wrap the low-level stream. You use the high-level stream, and the high-level stream transforms the value into whatever into whatever series of bytes it needs to be sent through the low-level stream. And this is the first classification. The second classification, which is much more easier to understand than this first classification, is the classification of streams in input stream or output streams. So let's now discuss the second classification before going into our code. So this is the first one. We say we have input streams. That's also read in terms of operation, or output streams or write streams. So whenever you see input or read, it's always this notion is always relevant to some application. And you say, for example, for app 1, this is an output stream because the arrow shows that the data, it goes out of the application. So we have an output or a write stream. The data is written or sent out of the application, and that makes this stream for app 1 to be an output stream. But if you look from the app 2 perspective, in my drawing here, in my visual here, the arrow shows that the data is going into the app. So what is here to observe is that app 2 will actually have to receive this data through an input stream. So from the point of view of app 2 needs an input or a read stream to get the data that was sent by app 1. So yes, in this case, I have in my visual represented it through only one pipe, but when we discuss in terms of applications, there are different objects. You will use a separate object in app 1 that should be an output stream because it sends the data. And of course, you will use a different object in app 2 that is a read or an input stream because it has to collect the data to get data into the application. So that's first of all the first two important classifications of streams and how you see them. Now let's get into an app itself. So I have already created here an empty project for us using the latest version, which is still 14, but in a couple of days or maybe 3 days from now on we'll have version 15. So expect me to create another video with the new features that have been released when the version will become generally available. I think in 3 days from now on. So yeah, this is an empty project, and we will start with small examples in which I will show you which are the most important classes you need to know. And again, I discuss mostly about the general important stuff, but I don't go into all the details, like all the methods you would need to learn, because you'd actually literally need to learn almost all the methods of these classes, especially from the low stream object output stream and sorry, not object, the output stream and input stream classes. But that's only for the OCP exam, so and that's something you should do only before the exam itself, and you'll probably forget afterwards, as I always do as well. So let me create a class here, say example1, and in class example1 we just create a main method, and I would like first to put here all the classes that I want to discuss with you today and in the next videos as well. Of course, I told you this is not only one lesson on IO streams, so we will have to discuss plenty of things about IO in general. So just to be aware, we'll have a lot of things to discuss still. I want first of all to enumerate all the classes that we will use throughout our demonstrations. And then we will take them one by one, and we'll do from simple operations to more complex operations, which will basically help you then do whatever you'd like with the streams. Of course, at some point you'll have to find things in the documentation, but if you learn the very basics, then you know how to work with any kind of a stream. So let's see which are basically the things that we need to learn. So we need to learn about, say, let me classify them in low level and high level. I will say like this better. Input stream and output stream, and then you have file input stream and file output stream. So these four classes are what we'll discuss in terms of low-level streams, and input stream and output stream are just generic. They are the generic input and output stream, and file input stream and file output stream are actually some more particular definitions that, as the name suggests, they are used to write or read from files. Pretty easy to observe that. So yes, we'll discuss in general about input stream and output stream as being the low-level streams, but I also like to introduce you at some point to the file input stream and file output stream classes, which you will find in examples with reading and writing into files. Even though with today's implementations that the JDK offers, you will see that in many cases you don't even have to bother with the low-level streams, and when we'll reach the lesson in which we'll discuss the new IO, the non-blocking IO implementations, and we'll discuss about paths and files and so on, you will see that I will introduce you to many syntaxes in which you will write in a couple of lines what you would have written in maybe 10 or 20 lines with the normal IO and using these classes. So we will progressively, I will also help you evolve from using these classes that are more or less becoming legacy today, but you still need to understand them even though they become legacy, and I will help you evolve to the new classes, the new implementations that allow you to do the same operations faster and easier. So stay on this path with me, and I will again teach you everything in step by step in a natural way in which you need to get them. And then of course we need to discuss about the high-level streams, because it would be a pain just to use low-level streams to actually to work with your data and to send your data. You'd have to actually read and write bytes and manipulate the bytes yourself, and this is something we don't want to do, especially not with Java, which is a very, very high-level language, and you don't want to bother with bytes too many times. So you will be very interested in high-level streams, and here is where we have buffered reader, buffered writer, object input stream, object output stream. We'll also use print stream, print writer, and I will only mention but will not really make examples with some older classes like data input stream and data output stream, just for you to have them here, so in the classification. And I know there are many classes here, which means that we'll have a lot of things to discuss, but again, don't worry, because I'm not going to actually take all of these classes and show you all the methods inside them, like I did with the string class, because yeah, string class is pretty important and you need to know most of those methods, and I wanted to make sure that that you are aware of everything. But here it's not that relevant, so I will show you more like examples that you need to get started, and then you will basically, with what I show you, you should be able to do whatever you'd like further. So it's not that we're going to lose a lot of time doing a lot of unnecessary stuff. And as you will see, then when we'll reach this this point with object input stream and object output stream, we'll also have to discuss about serializable and serialization, which is a mechanism in Java which is pretty important, even though again it's it's less and less seen and used today, but you will still see it and maybe encounter it here and there, and of course in the OCP exam, and we'll discuss it as well together with the object output stream and object input stream classes. And that's actually before going into the file system itself. And at some point, once we finish with the streams, we'll discuss the, I will write it explicitly here, Java IO file class, which is, as I will also mention in the next lessons, sorry for this, which is actually legacy. I will recommend you not to use it anymore if possible. So starting with Java 8, we have other better options for referring to files and to the file system, and of course then we will discuss those options which are in the Java Neo package, and we have paths and files, and that's where you should not make a confusion. Files and file are two different classes, and in the questions of the OCP exam, I've pretty much found a lot of cases in which these two names are reversed just to trick the student and yeah, make them lose points, which is not really fair, but that's how certifications usually work, so get used to that. You'll have to pay attention to which class is used in that question in order not to yeah, miss the question, of course. So this is basically what we'll be doing, and I will start with the easiest example, and the easiest example with our discussion is SystemOutPrint. So maybe you'll be thrilled to hear that SystemOutPrint is actually referring to IO streams. So this is actually IO streams, and that's because when you actually call print line here and you send the parameter, which you know basically that's what you will see in the console afterwards, because SystemOutPrint line in Java is just writing something to the console, and this is something you know from the very first lesson of Java, where you write your first hello world. But this instruction here is much more complex than you can imagine, so we always use this in our first examples because it's the easiest way in Java to write something in the console, but it's actually a more complex instruction than some beginner would imagine. And that's because, of course, we have here sort of static dereferentiation, non-static dereferentiation, and so on, but even more than this is actually a behavior that's a part of an output stream, which happens to be a high-level stream. So did you ever wonder this object out that you use when you write SystemOutPrint line? What is it actually? This is actually a high-level stream, and it's actually a stream created with the class printStream, which is one of the classes I have enumerated here. So printStream is the class that's defining this out here, and you can actually go to it and see that. So you can see printStream it's nothing else than a static final reference of an object of type print stream, which is one of the types I have enumerated earlier as being a high level stream. So when you use print or print line, you use a high level stream to send that information into the console. And the reason why you can actually write a string here is because print stream is high level. Because if print stream would have been a low level stream, then you would have had to transform this string into bytes and send it as bytes. Otherwise it wouldn't work. But instead, the print stream object will do this for you, and you can just write there a number or a string or whatever you want, and you don't care about transforming it into the bytes that need to be sent through the low level stream. And now I will do a parallel to this. This is my first example, and then I will create a separate example to class, and I will make a parallel to this example with reading something from the console. And there are many ways we can read from the console, but now I will focus to that say twin to system out, which is system in. So maybe you've actually heard about system in as well. But is it that you didn't actually use it so much? You didn't actually use system in so much when you've read from a console? You've maybe used system in, but you most probably never used it directly. If you will take a look, you will see that in has actually a method that is called read. So have you ever used this method? Maybe you had, but it's much more probable that you have actually used other means to read information from the console than directly this method read. And the reason why I say that is because, as you can see, this method is actually reading bytes. So the reason why this method is reading bytes is because, unlike system out, unlike the out object of the class system, this in is actually a low-level stream. You see, if you go into its implementation, you'll actually see that the variable is declared using the input stream class, which I have classified it here as being low level, and low level uses and works directly with bytes. So here is where the difference comes from, and here's why most probably you didn't use directly system in read before to actually read details from the console, and you used other means to do that. And most probably when you've read something from the console, you have used the Java util scanner class. But that's not what I'm going to discuss now, because this scanner class is just an utilitary class, it's not part of the stream, so I'd like to not focus to it for the moment. So let's just continue discussing about system in. But I would like to show you that you can actually wrap this input stream, which is a low level stream, into a high level stream and use it this way to read data from the console. So what we will actually do is precisely what I've tried to represent here in my visual. So what we've seen in my visual here, where I said we have low level streams, and then they are wrapped into high level streams, and when we use it, we don't use the low level stream. So we don't use system in to read from the console directly, because it's a headache to do that. But we can wrap this system in into high level stream, and then we use the high level stream to do that operation. So instead of taking care of transforming those bytes that we get ourselves, we just leave the high level stream do that for us. And let's see how this works. And I will just take one of the high level classes that I can use from here. So remember that besides classifying the streams into low level and high level, we have also classified them into input and output. But fortunately for you, it's very easy to just see which is an input and which is an output stream in Java, because the names of the classes usually contain input or write for whatever refers to input or read to whatever refers to getting data, respectively output or or write to whatever refers to sending data. So that's why I don't have to tell you that this is an input stream because the name suggests it. I don't have to tell you that this is an output stream because the name suggests it, and so on and so forth. So everywhere you will see something that tells you a print is also a write. So this is an output stream, this is an output stream, this is an input stream, output stream, input stream, output stream. So you can very easily see which is an input and which is an output stream. You don't have to memorize them, you don't have to know them by heart. And I will basically need to read here. I think it's clear for you that I need to get data from the console into my application. So that actually means I need to get the data into my application. So I need to read data. So I need to get here from this, I need to just get an input stream and use that input stream to wrap my system in and get the data from the system in into my application. And of course I can use data input stream, but this is old and legacy, and I prefer to skip it for reasons that I will explain later when we will make a comparison between what we'll name buffered streams and non-buffered streams. Of course I will use the next class that's an input stream here, which is bufferedreader. So this is the best option I have. I could have actually used object input stream, which you can see is the third implementation of a high-level input stream I have enumerated here, but as you will see later, we generally use object input stream when we deal with object instances. So in my case, I would like actually just to read a string from the console, from the terminal, so I don't need actually more than a buffered reader for that. And this is the first high-level implementation I will use. So I have the input stream. Where is it? Sorry, here in example 2. I have the input stream. This is my input stream. I need to wrap it into an output stream. So what I want to do is something like buffered reader in is new buffered reader. Okay, and theoretically somehow you should get your system in to the buffered reader, so buffered reader uses it to read and get the data for us. And you will actually see that this constructor I'm using here requests a parameter. So if I'm going, you will see that I don't have actually an option to use the buffered reader without a parameter. I have a couple of overloaded constructors here, but both of them have parameters, and I will further refer to the simplest and basically I would say only one that you will actually use, which is this buffered reader that contains as a parameter an object of the type reader. So let's see what is this reader type. This reader type is just an abstraction that represents an object which tells the input stream how to read the data. So the reader is is telling the stream in which fashion the data should be read. And we have actually more implementations of this reader abstraction. And two of these implementations are the most important that you actually need to know, and that is the input stream reader and the file reader. And basically, again, these are the most important reader implementations. If you go here, you can see that you have plenty of other reader implementations. Many of them I've never seen, many of them I've never used. Some of them are internal classes. ComSun, for example, it's an internal implementation. You shouldn't use it outside. But anyway, the whole idea is that for you, important is to know about the file reader and the input stream reader. And generally, these are the ones that you can use to create an idea about what a reader is and how it works, as well as these are those implementations that you will basically find eventually in your OCP 11 exam questions. So what we've learned from here is that we cannot actually directly create a buffered reader instance over the low-level input stream, because first of all, we need to tell buffered reader how to read the data. and we will use one of these two implementations. I will actually start with the first one here, and I will use filereader. When reading from a text file, you will see that filereader is an implementation of reader that tells the high-level input stream to read the data char by char, and that's why it's usually faster when working with a file, with a text file, and we usually use this filereader when reading from a text file. Otherwise, if what you want to read, it's only a series of bytes that you will eventually transform in something later, like a string in my case, you can use an input stream reader. So now what I will actually do, before trying to create my buffered reader, I will create the input stream reader new input stream reader. And what you will see here is that the input stream reader, what it receives as a parameter is directly the input stream, which is natural. So the input stream reader, it's wrapping the input stream, and then buffered reader, which is the high level stream, reads in a specific fashion the data through the reader from the input stream. So you have high level stream uses the reader to get the data from the input stream, which in our case is system_in. So from system_in I'd like to read, the reader becomes the parameter of the buffered reader, and finally in the end I have the buffered reader object which allows me to read the data. Now I will say read line, which is the behavior of buffered reader that's getting a line from the console. So when I will write something and press enter, this will return that string as a line. And one of the most important things you need to know again from the beginning, that's relevant usually for your OCP exam questions, is that you will always get a couple of checked exceptions in code that's working with streams. And the exceptions you need to remember are IO exception and file not found exception, that we will constantly see from now on when working with streams. So you should remember that file not found exception is actually extending IO exception. This is something that I might have told you also when working with exceptions, because these exceptions are quite often found in the OCP exam questions. So you need to know about IO exception and file not found exception. They are some of the basic exceptions that you need to remember. But they are now certainly more important for us, because this is actually the code where we will face them in our examples. In this lesson and the next lessons, we'll continuously see one of these exceptions being thrown. And in my case, of course, you might have guessed that the code line 19 here failing to compile is actually because of an IO exception that's being thrown. And IO exception being a checked exception, you need to treat it, you need to throw it, but you cannot actually leave it like this, otherwise the compiler will actually fail to compile your code. So we can, because we've learned how to use a try catch, we can actually wrap our line into a try catch, and this way our problem will disappear. Line system out, and this is actually just taking something from the console and printing it into the printing it in the console again. So I take something from the console, what I write, and then I print it on the next line. Something very easy, a very simple demonstration, but what I wanted to share with you in this example is how buffered reader works, how high level streams works, how low level streams works, the link between them, because I've seen so many times people knowing to write buffered reader is new input stream reader of some input stream. So usually writing the syntax or copying it from somewhere, Stack Overflow, whatever, but not necessarily understanding what's behind. And this is really unfortunate from my point of view. You always, when you see something, when you are in a situation in which you see yourself using something but you don't understand it, never just copy paste it, because if you don't understand something, that something might come with, I don't know, might come with some things that if you don't know that you don't know, to say it like this, you might introduce bugs or vulnerabilities into your applications. So it's really important to know what you are using, not only copy pasting it from somewhere. Even if it looks like it's working, it might still have problems. When you don't know how something works, you easily introduce bugs and vulnerabilities into your application. So yeah, now that we have seen and hopefully understood line by line now how this works, let's test it to see that's actually working and doing what I've said it's working, how I said it should be working. And then I will show you how you will very often find this defined in real world examples. So you see the console now stopped here and it's waiting for me to write something, and I can write whatever I want, hello, and then when I press enter, when I actually written this hello, I was on this line. So my application was blocked on this line. It was waiting for me to type something. And I pressed enter, and on line 22nd, whatever I've written was concatenated with this prefix here, and then I see this output into my console, and then everything stops because the application ends here. So that's basically how things are working. And now let me also refactor codes. Refactor, it's not like really a refactoring, but I just like to write also this text the way it is, but also in the fashion in which is most probably that you will find it in code. So when you will see this, basically one mention here is that you will rarely see this code written as the input stream first and then the buffered reader on the second line. Most often people will actually just take this and put it directly here. First, that's the first thing. Then the second thing I'd like to mention is that starting with version 11, you have the var word that you can use. This reserved time name, it's not necessarily something that you should use in real world scenarios, but it's something that I've seen is now very, very often used in OCP exam questions. So be aware that you will see something like this plenty of times in your OCP. Thank you very much for your appreciations, guys. So yes, this is something that you will see very often starting with version 11. So if you go to the OCP 11 exam, expect to see that var word here and there, and yeah, get used to it because you will see it. And now the last but maybe the most important thing, streams are resources. And I will for like a refresher for you now, a resource, what we name a resource in Java is an object that always when you create, you say that you open that resource, and always at the end you need to close it. So that's why you always need to have a finally and say something like this, close. And you see here that close as well throws an exception. So when you do something like this, you have to add a try catch here as well. And eventually, when you do something like this, you are not sure that this actually worked and this didn't actually. In this case, you are sure that it worked the way I've written the code. But sometimes you can write the code differently, I would say, and you are not sure that when it gets here, in actually has a value. And sometimes you might even need to say if in is not null. Now this is a syntax that it was used like this previously to Java 8. So in Java 7, for example, you would see something like this whenever you're using with streams. You would see something like a finally, a very ugly and big finally of maybe 10 lines of code there with try and catch, with an if clause. Ooh, really, really ugly. I don't want to see this something like this anymore. This is only in old applications. Remember that starting with Java 7, Java introduced this term of resource in try-catch as well, and you started to have the possibility to write the syntax that is called try with resources. And this is a syntax that we have discussed some time ago, a few lessons ago, when we have discussed try-catch finally block. I've told you that you have the possibility to use some round parentheses here, and inside this round parentheses you can declare objects that are resources. Objects that are resources are objects which in Java implement the auto-closable interface. Fortunately, all the streams have been changed as well so that they are resources. So instead of writing this ugly finally block here, you just avoid writing it by opening the round parentheses and putting your declaration here like this. And now it looks more decent. First of all, I didn't need to declare both objects on two separate lines because they are anyway dependent one to the other. So the buffered reader uses a specific kind of reader that tells it how to read the information from a low-level stream. And now it also became a resource in the try with resources, which implies that at the end of the try, automatically the try-catch finally structure will close this stream, and it doesn't expect me to do that. And this is really important not to forget about streams. And another thing, the last one, and I will stop with our today's examples, of course, but the next lesson will show you pretty more of the things that we have to discuss out of these classes that I've told you are part of this chapter. The last thing for today is to remind you that starting with Java 9, hopefully I don't make a mistake, but I think it was Java 9, but now we have a 14, so I'm sure it will work. I'm using Java 14, but starting with Java 9 anyway, should it be 9? I think it was 9, yes, 9. I hope I'm not wrong, but I think it was 9, when this started to be optional to be declared instantiated inside the round parentheses. So in Java 8, it was not possible to declare this outside and then only mention it here like this. But you see, with Java 14 it's working, and actually it starts to work out with Java 9. It's possible to declare first the stream or whatever the resource is, and then you can only mention it. I personally don't like this syntax very much. I don't recommend it. And the reason I don't recommend is because putting it here now, whenever this try ends, it will close the stream. So anyway, using the stream here would mean to use a closed stream, which is I'm not sure how much relevant is to actually use a closed stream anyway. So that's why I generally still prefer to declare it, all of it, inside the try block here, as you have seen me doing in example 3. So I prefer this syntax. But you need to be aware that starting with Java 9 and 11 for sure has it, it's possible to do something like this. And that's because you might find this in your OCP 11 exam questions. So if you find this syntax, if you are going to OCP 8 and you find such a syntax, and you might find it, I've seen it myself, that's not working. So with Java 8 this syntax isn't working, so that in OCP 8, if what you are going to do is take that OCP 8, then this doesn't work. It's a compilation problem here. But if you find it in OCP 11, then this is good. So this syntax works. You see, it has no problem. We can run it, and you can see it's basically working as you expect. It's just reading the string from the console. Okay, so you see it's actually working. Good. So for the moment, let's conclude here our lesson, because we don't have any more time, and it always my recommendation is that you should not spend a lot of time like focusing on a specific thing. I always say that try an hour, maybe a couple of hours, but always take a break in between and do some other things as well, like, I don't know, playing the guitar or whatever you'd like. But take a break and just don't try to focus too much at the same time on a specific subject. So let's conclude for today's lesson as well, and we continue with the other classes, implementations and subjects related to IO streams and working with the file system as well in the next lesson. Until then, thank you very much for watching, and thank you very much for being here with me and for all your appreciations. I saw them. And have a great time for learning further.